Hello everyone! Today I will talk about how you can automatically test regular expressions and do it in such a way that you don't do anything at all. Does that sound like magic? Yes, but it's nice when you don't do anything and the work is done and we go. I hope everyone is familiar with what a regular expression is, and yes, usually regular expressions look like some kind of absolutely meaningless, poorly understood, poorly readable sequence of letters, numbers, and special characters. And it's very difficult to understand, and by the way, that's one of the main problems with regular expressions, in my opinion. What might this problem look like? And so you have some set of some letters, numbers, signs, parentheses, questions, and this is a regular expression, and looking at it, it's very difficult to understand what it's about. These are the examples I'm going to show you now. I just took them from Gothab, typed Regex in the search for regular expressions, and these are the examples. Here, the situation is a little better. Yes, it is written here that there is a certain balance, a certain incoming, but it is still not very clear what kind of numbers there are. Some spaces in parentheses, what is it? I would like to see some description in general. What is this to solve the problem of understanding regular expressions? Many people sign comments to them. Well, for example, how is the comment signed here? Apparently someone is looking for here, but it is not clear what is happening here. Even looking at this comment, I don't understand what is happening or how. In this example, it says here that the regular expression should check if the pattern is an email. We all know what email looks like. In general, this is quite enough, but we want more. We want to see concrete examples of using regular expressions. And yes, the most advanced developers create special unit tests for regular expressions. This is a very good practice. I fully support it, but to be honest, I would be too lazy to write all the time. These are the words test, invent cases, classes, invent names for these tests. This is what a computer is supposed to do on its own. And here I would like to take a little lyrical detour and ask if everyone is familiar with this wonderful man. I hope many of you recognize him, and this is Henry Altschuler, the author of the theory of inventive problem solving. I will say right away that the theory of solving inventive problems is very often accompanied by attempts to apply it to the field of software development, but due to the fact that initially it is very strongly focused on mechanics, then there is naturally no complete correspondence. This can be discussed at length and separately. But there are some points in the theory of solving inventive problems that are quite suitable for the programming industry. For example, one of these points states that there is such a thing as an ideal object. What is the ideal object? An ideal object is an object that performs its functions but does not exist. Sounds like magic. Well, let's see if this magic still exists. Let's define a regular expression that will search for a social security number. Well, look for it, check it, yes, in the text. Here we have defined it. This is a typical step that is always present in any work with regulars. What do we do next? Next, we install a special package called Regex TestAdapter. We install this package, and after that, we have the opportunity to create attributes. And these attributes allow you to indicate that this regular expression of data with CH must match. This is the text. Well, actually, this is the format of this very social security number, several groups of numbers and separated by dashes. Okay, we determined that we can directly take and write a specific example of what we want to coincide with this regular, but very often there are some things that kind of contradict what we want. For example, we would like to have matches are numbers like these, but we wouldn't want us to, for example, mistake phone numbers for social security numbers. That is, we can indicate from the opposite, we want to soak this and we don't want to soak. That's it. And naturally, as always, in any industry there are certain border zones. We might want to see simply, but what happens if our regular expression encounters a record format like this? At the same time, we do not want this to be considered either a mistake or conversely something right. We just need to know what happens if the regular expression meets this particular writing format. What else needs to be done? And here my favorite is nothing. Magic will happen next. Let's throw on a few more regulars, for example, and actually make magic, and magic will look like this. We have unicorns. By the way, I may have forgotten to say that all this is necessary. Naturally, do it in the test project solution. Now we have tests, we can even navigating them. Let's see what might happen if we right-click on any of these tests and see the gold test. And we don't have this test. What will happen if we do? There will be a test. But actually, we will go to this very attribute that shows where we have the description. This is an example of regularity, by the way. You probably noticed on the previous slide. One example was with an error. Naturally, as always, everyone is interested. But what kind of mistake did the speaker make? Well, let's consider. And I specifically made an example with an error when regular expression syntax is missing parentheses. Well, actually, immediately, a test that checks our regulars. He detects it. He writes that, look, we have the wrong pattern in this position. We don't have brackets there. What else is possible? We want to see some additional diagnostics. Yes, we want to see that, for example, the captcha group finds something. Yes, please, we can look at the the details of the elbow and see what is written there. Well, it actually says that the pattern of this test of this group discovered this. Numbers in such positions, that is, we can see that everything in fact coincides with our idea that we wanted to find specific numbers in a specific group. Well, actually, here it is. This means that magic exists. Now, I'll tell you a little at a very high level how all this works and why it's not just about regulars. Let's break down some details. In order for all this to work, all this magic to exist, I implemented it in the very well packet that I talked about. By the way, all the sources are available. You can download it, watch it, play it. So we need to implement the its discovery interface. The implementation of this interface should return us a list of test descriptors and what is important. The tests themselves can be described in any way. I used attributes over string constants, for example. But if you want, you can just use a plain text file and call it high spec. I made mine an even better. So what is there? In this description of the test, the description of the test is called a test case. Well, actually, there is a name there, which will be displayed in the list when you run the tests. That is, you don't need to manually come up with a name. In this case, it is generated for me from the name of the test name attribute, and so on. And actually, here are the same two links that I showed what should happen when you want to move from test to source in a test. Well, actually, that's the name of the file, and the position in this file means what else needs to be done. After we have done the discovery test, we need a test, an executor, a test, an executor. As it is not difficult to guess, it must run the actual logic of ours. These are the descriptions of the tests. That is, in step 1, we discovered all the tests that we have in the system, and in step 2, we directly perform these tests themselves. In my case, the exciter test checks the equality of the string given in the attribute to match. One expression you have, it can be something else. How the results are displayed. After running, we create some kind of result descriptor in which we indicate what actually happened to the test. He passed us, he didn't. What kind of test was this? And some set of messages which you saw in my example. As I was figuring out how it works, I discovered one very funny fact. A fun fact is that the interface of the iTest exeter is not made very well from the point of view of the principles of solid, which is specifically the violation. The violation is that the IT test executor interface requires the implementation of no method. As it would seem, yes, that is, we have the AI discovery test that found the tests, and we should have the exeter test that should run them, but no. We have two methods in test executor. One of them, yes, really runs all the tests according to the list that were found. And method 2 runs all the tests that it should find itself. That is, we have a violation. This is the principle of single availability. Yes, that is, we have one class that must find another to run. But the authors added that the launcher is also a search engine itself. Why is this done? I don't know, but there might be one small problem with that. If you have even a slight difference in implementing any of these logic, the difference is that one of these methods will be called when you run the tests. From I see the studio, when you select a test with the mouse and say run, and 2 will run when you run it, say on the build pipeline with the .NETest command. And if you have some difference between these two methods, even if it is small but it can play, that is, as a result, you can see that your tests run differently. Why is this done? I don't know. Most likely there will be some excuses in the style that has historically developed, but here is a specific example when the principle of single expansibility is violated and the results are not very good. What else do I want to say about the method by which this magic of automatic regular expression testing is achieved? And here everything is simple. In many very projects that I have seen, there are units, tests, unit tests that are not actually unit tests. These are just launchers for some very high-level tests that relate to a specific subject area. And specifically now, for example, when there is a boom in machine learning, yes, very often tests described in their own words, files, and something else, yes, but at the same time, developers often try to wrap it all as if in a unit. Tests very often write them by hand, or even make some generators that generate these tests. Well, in fact, everything can just be used. Here's the TestAdapter, and the TestAdapter will give you the ability to run anything you want as tests. This means that all files in the repository are completely open. You can copy or clone if you want. You are prohibited from using, well, you can just copy getpacks and even say that you came up with it all yourself. In general, put likes, subscribe to the channel, write a question, and I will be very pleased. Thank you all for now.